Too good, gentlemen.
Hello, and welcome to this month's Azure Container Apps community live stream. Joining me today is Cary. Mike is also somewhere here as well. I'm not sure where he is, but during the music just now, I think he turned on his mic and said something, so you probably heard him. So today we're going to do the usual, cover some community highlights and some product updates. And then we thought that we would do a deep dive into a couple of kind of pretty common topics that come up, which are scaling and troubleshooting. So I'm going to be going over, how scaling works in container apps, and talk about how you can set up your scale rules, and also how scaling applies to jobs. And then Mike's going to come on and talk to us about how to troubleshoot your container apps using the existing observability tools that we have in container apps. So to kick us off, we're going to have Cary, who's going to show us a bunch of community highlights.
Hello, everybody. Excited to be here. So starting off, we just put out the newsletter yesterday for September. So just recapturing all the different things that have been going on. We have all the links to the community highlights that we're about to share, as well as some links to our upcoming events we'll talk a little bit about, and then product news. So let's dive right into it. So the first article we have here, and apologies to these folks if I get the names wrong, but Asta has a great article on init containers on Azure Container Apps. She gives a great explanation of what exactly is init containers in a very understandable way, as well as this great animation to explain what it does, and some breakdown of how you can use them. Next up, we have how to use Azure Container App Service for efficient app deployment, a DevOps guide. And this is by Radha. And she gives a really great example of different use cases that you can have, as well as just a really in-depth explanation of deploying a Next.js app onto Azure Container Apps and all the different steps, including scaling into from local all the way to deploying to Dockerizing and deploying to ACR, and then deploying to Azure Container Apps finally. Next up, we have this article that came up on Stackify about different Kubernetes services in the cloud. But they focus really on Azure Container Apps, and they give a great breakdown from their perspective of, hey, what are the really cool points about Azure Container Apps? What are the awesome features? And then also, what are some of the limitations? So if you're looking into trying to understand what are some of the differences between these container services, this is a great article potentially for you. Next up, we have this article from Massimo on the recent workload profiles that we have G8. He does a deep dive into Azure Container Apps on workload profiles, giving an explanation of the benefits that they provide, as well as answering some questions that he's seen come up in his own experience, like how many nodes can you put in a /27 subnet and things like that. So if you're looking to learn more about workload profiles, understand perspective about how they are useful potentially in your development, this is a great article to refer to. Next up, we actually have Massimo's own blog, so same author. But he goes into a great article here on cron jobs on Azure Container Apps, how to use them, running them on ACA jobs, and as well as on Azure Container Apps themselves. Next up, this article isn't exactly directly for Azure Container Apps, but this is more of a step-by-step guide for Azure Container Registry and managing access there. So if you're looking to manage access to your ACR, this is a great in-depth article that breaks down all the different steps for you, has a Terraform resource. So this is a great place to refer to. And then finally, we have this article here by Anthony on, different Anthony though, for profiling Go applications for performance issues. So they go through the different steps of what you're going to want to be looking at in the local development, as well as how you can use storage mounts and Azure Container Apps to get them added as volume. So this is a good in-depth article here. For some product updates, we had a lot of product updates last month, so not as many this month. But there's two really big ones we wanted to call out. So for one, we're generally available with Azure Container Apps and Azure China Cloud. So anybody looking to deploy in China regions, this is now available for you, eligible for the Azure Savings Plan for compute. And this is really great if you're aware of how much compute you're going to need for the next 1 year, 3 year, however many years periods. And you can get some good discounts with Azure Container Apps if you pre-allocate that. And with that, Daria has also put together this great article really explaining in depth the savings plan and how to get started with it today. Finally, I did want to also just call out that we do have some additional sessions coming up this month. So we have Ask the Expert, Build Intelligent Apps with Azure Container Apps. There's two options for this session. There's one on October 18th. Both of them are on October 18th, but at different time points. PST, if you're in a different time zone, that might vary into October 19th. But exact timestamps are on our newsletter right here in the upcoming events. I think with that, thank you, Anthony, and I think I'm going to hand it off to you, right, to talk about scaling with jobs.
Yep, cool. And just want to call out that the link to the newsletter is aka.ms/containerapps/newsletter. So all those links that Cary talked about earlier, as well as the links to the Ask the Expert sessions, you can go and check out the newsletter to get those links. Alrighty. So yeah, so next thing that we wanted to talk about is, actually, I need to get ready for this. I'm such a professional. One moment.
This is how you know it's natural, you know?
That's right.
Getting a real life experience.
That's right. Yeah, I forgot that. I forgot that I prepared slides for this. So this is how you know this is the real thing. So like, this is getting serious because I got slides. So I'm going to go and talk about some scaling with container apps. Yeah, so let's dive right into it. I'll make this thing large-ish. Yeah, so there's actually different types of scaling. So I thought I'd kind of like start from like basically the very basics and talk about the different types of scaling that you can have, and then talk about automated scaling and how you can configure scaling in container apps. So there's different types of scaling. So one that you might be aware of is vertical scaling. And in container apps, that's controlled by how much CPUs and cores, CPU cores and memory that you allocate to your container app. And to kind of scale your container app up, you would basically deploy a new revision of it, and then you change the container so that it would have more. I'll check out this animation. Look at that. So you can basically have have an app that uses more CPU cores and memory, and that's one way to scale. But one challenge that you can run into with this is, you'll get to a certain point where you can't get a bigger machine anymore. The recent dedicated plan that we announced with the workload profiles, that helps a bit because you can now have some pretty large machines that you can deploy your apps to. But that's still, there's still some limits there. So ideally what we do is we do horizontal scaling. So instead of scaling your app up and down, you're actually scaling it in and out. So when you need more compute, you can scale your app out. And this is controlled by the minimum and maximum replicas sliders on the container app resource. So if you want to scale your app manually, you would just basically set the min and the max to the same value. So in this case, I set it to 5, and you would have 5 replicas of your application. So if it happens to be an HTTP application, then your traffic will be round robin to all of these replicas. Cool. All right, so let's talk about auto scaling and an HTTP app on container apps. So this is the normal setup today. You have a user kind of using a browser that's talking to your app. It's talking to it through the ingress. And if all of a sudden there's a bunch of users or connect devices or browsers connecting, your ingress is going to actually notice, hey, there's actually a lot of stuff going on, and then we might want to scale out. And if we have the rules configured properly, the app is actually going to scale out to multiple replicas, and then the requests are going to get distributed amongst the different replicas, and then the app is happy. And then when the load kind of disappears, then the app is going to start scaling back in, and we can also actually scale in all the way down to 0 when there's actually no traffic. And then when we notice traffic, then we'll scale you out again. So that's in a nutshell, that's how HTTP scaling works. And I can show you kind of quick demo of that here. Not that yet. So I just have a hello world kind of app here. Let's look at how many replicas that we have. We have no replicas. So so there's a bit of a cold start when we first open the app. I think it's about 10 seconds or so. While that's happening, let me bring up my console. And then I'm going to go ahead and hit this website with something like 10,000 requests at the same time. That's going, we don't have to see that. We'll move that off the screen. And then if we come back here to the app and we look at the replicas again, you'll see pretty quickly that that a bunch of replicas are being spun up. One thing I didn't show you before, you kind of might have seen it on the screen, is that I have it configured to scale between 0 and 20 replicas. So to set up a scale rule, there's typically two things you want to do. One is you want to set up the range. So that's how many replicas that your app will have at any given time, and the minimum and maximum of that. And then the scale rule actually decides how many replicas your app actually needs within that range. So the rule that I set up is 5 concurrent requests equals basically one replica. So in this case, it saw way more than that, and then it decides that my app needs 50 replicas. Oh, sorry, 20 replicas. And that's what we're seeing here. So if we refresh it, just to make sure, you can see all the replicas are up. And yeah, so that took about a minute or so, and we now have 20 replicas of our app.
That's super cool how many instances we can get so fast with that scale rule there.
Yeah, it's actually pretty fun, just like scaling the thing in and out.
And with that though, is it like if I as a customer, if I'm coming in, I'm doing those scaling, like I'm getting all these different replicas, am I paying for each of those replicas individually? Like, how does that work out?
Yeah, so you only pay when the replicas are running. So when the replica starts, I think the current cooldown period is about 5 minutes. So if there's no more traffic that needs to stick around and serve, it's going to disappear in about 5 minutes, and you only pay for the time that your replicas are up and running.
Okay, nice.
Cool. Let's see if there are any questions. Oh, there are. Okay, so we have a question about what about Azure DevOps agents? I will touch on that a little bit later when we talk about jobs. So you can run Azure DevOps agents as container apps, Azure Container Apps instead of jobs. But we find that jobs actually work better for that scenario. So you can set up scaling either way for both of those. But I'll probably touch on that when we talk about jobs a little bit later. Okay. let's okay. So with that, that was HTTP scaling. Let's talk about other things. Cool. So the other type of app that you might want to write is it's an event-driven app. So and so typically what these apps do, like a pretty canonical example is an app that goes out and looks at and basically asks a queue for messages and kind of grabs messages off of a queue and processes them. And you can scale these apps as well. So yeah, so this is what the app does, and I think I have some code. So this is some very basic code about what this app actually does. So when the app starts up, it's just going to go into this loop that just keeps grabbing messages from a queue, processes the message, and then deletes the message from the queue. And then you can start more than one replica of this app, and then they basically implement the competing consumer pattern to just basically go and ask for the next message from the queue. So you can have many of these running. So how you can set up auto scaling for this, and you actually don't have to set up auto scaling if you don't want to. Say you wanted 5 replicas of your app, you can kind of did what I kind of mentioned before, which is you can set the minimum and maximum replicas to 5, and your app will always run 5 replicas. But of course, we can do better than that, and we can do this using Kata, which is built into Azure Container Apps. So whenever you define a scale rule in Container Apps, behind the scenes is actually using Kata. And what Kata does is that it also watches the queue. So you can configure Kata to say that, hey, my app needs this, is using this queue. Can you please watch it? And then what it does is that it will notice that, hey, there's a bunch of messages on the queue. And basically, Kata just does some math and goes based on, like your configuration. Right now, given the number of messages on this queue, you need maybe 5 replicas. So it's going to go and get the container app to scale out to 5 replicas. And now, all of those replicas are going to keep grabbing messages from the queue. And theoretically, that should process these things, 5 times faster. And then we're happy again. And then I think just like before, Kata can also scale you all the way down to 0. So when there are no messages in the queue, there's nothing running in your app. But Kata is it's continuously checking the queue for you. We don't actually charge you for Kata. So when it kind of notices a message again, then your app is going to scale out to 1, 3, 5, or whatever you've kind of configured your scaler to scale out to. Cool. So there are some scalers here. Most of the Kata scalers are, whoa, it's opening a link. Most of the Kata scalers are supported. So we have a bunch of scalers for Azure. You can see that we have, the very popular ones are Event Hubs, Storage Queues, and Service Bus. But we also have Blob Storage, Log Analytics, things like that. You can also scale on some open source components like Kafka or RabbitMQ if you have that running in your Container Apps environment. And you can also set it up for the very basic kind of scaling that we used to do. I think it's still useful sometimes, but less so. It's you can actually configure scaling based on how much CPU your app is using, as well as memory. And you can also actually have it, watch other things in other clouds. So there's scalers for AWS, Google, all sorts of things. So so each one of these have a scale rule kind of schema that you can look at, and these translate pretty much directly to a container apps scale rule. So you'll notice here in this particular scale rule is that we're watching a queue called orders, and then we're expecting a queue length of 5. So what it's going to do is it's actually just going to do some math. So say there's 20 messages in the queue, it's going to divide that by 5, and then it's going to come up with an answer which is 4, and that's how many replicas it's going to try to scale out to. And so you can actually control that by changing that value. The rest of this, the rest of these are kind of advanced settings. So you really only need to know about the first 2. So I'll kind of show you how this works in an app that I've already set up. So I have an app here. If I head over to scale, you can see I have a scale or our queue scaler set up. And it's the same, like you kind of notice the same values as before. So I am scaling based on a queue named images. So like these messages contain a URL to an image. And the idea is that I have a container app that keeps grabbing these messages from the queue, and every time it sees the URL, it's going to download the image. It's going to classify whether there's a dog or a cat in the image, and then it's going to output it to a container app. So, and I've set it up to a queue length of 10. So, so when there's under 10 messages in a queue, it's just going to have it at 1 replica. But when it goes over that, it's going to use that to do the math to figure out how many more replicas to add. So yeah, and then I also gave it the connection string to the to the queue, so that it's so that Kada itself is able to access the queue and see how many messages there are to do the scaling. Okay, so there's actually a front end to this app, which is here. I ran this a little bit earlier. So I can click classify images for 10. You can see that I'm not sure whether it's scaled down yet. I just tested it maybe 10 minutes ago. So it looks like it's got 2 or 3 replicas just kind of hanging out working. So it kind of like, takes maybe a second or two to process each image. So the more replicas that we have start up, the more images that we can process in parallel. So I'll go ahead and set this to, let's just crank it to the max, to 5,000 images. And what we should see is that container apps, so first of all, it's going to take a little while for the images, or for the 5,000 messages to get queued up in the queue. But now you can see that the 3 replicas that are currently running are already kind of picking up those messages. But as the Kada scaler starts noticing that there is basically all of a sudden there's a pile of messages in the queue, it's going to go and start scaling out the app. So we can go back here and look at replicas. If I refresh, you can see that all like that it's already starting to scale out. So currently it's trying to add maybe 10 replicas. It's probably going to go beyond that. I have it set to 50. So it should go up to 50. It usually takes about 2 or 3 minutes for this to fully happen. And also the container itself, it's a little bit large. It's running TensorFlow. And so it might take, 20 seconds or so for it to pull down the image, and then it has to start up. So there's a little bit of a cold start, but usually within about 3 or 4 minutes, I think this particular app would have scaled out to the max. So you can see that it's already up to 7 replicas. And I think we would just, if we stick around long enough, it's going to keep going up and up and up. And
that's super cool.
Yeah.
Just
although I did train the model myself, so I'm not sure if it's that accurate. But
I mean, everything that I'm seeing so far is pretty
in,
accurate. I don't think I've seen a dog labeled as a cat so far. I might have missed it though.
Yeah.
For the replica count, I see you have in the top right there, Anthony. I know like we can go to portal and we can go like see like how many replicas we have, but how are you getting that replica count up there? Is there some sort of API we can pull, or?
There probably is, but this is actually more basic than that. So basically what's happening is that these replicas are spinning up, and then they're going and grabbing these messages off the queue, and then it's kind of processing these images. And each time that it comes up with a result, it basically sends a message back to this front end app. And this front end app has a WebSocket connection. So it's actually live updating it. So basically the back end is actually sending these new results to the front end. And it's just some JavaScript that I wrote that kind of figures out currently how many replicas are reporting results. So as you kind of see more and more come in, that's kind of how it kind of figures out. But you can go to the portal and see. So we should be at the full 50 now, although maybe not all 50 are up and running. Yeah. So yeah, most of them are are up and running. So you should see them kick up to 50 pretty soon. So you can see we're up at 42.
That's super cool.
Yeah. Cool. Yeah. Can't even see them anymore. Okay, cool. So that is event-driven scaling for container apps. So I'll quickly talk about jobs as well, because as of a few months ago, we introduced Azure Container Apps jobs. So there's the main difference between apps and jobs is that apps are expected to kind of run forever. So in this case, like so far the apps that we run, you kind of saw that. Actually, I think I might have a slide here. So far apps, are things that kind of run kind of forever. You can see that's in a while true loop. So it's going to, as long as the app is up and running, it's going to keep pulling messages from the queue. So that's how apps are expected to work. But there are some times where you actually want to just run some code and then just have the process exit. So that's what jobs are for. So you can actually write event-driven jobs as well. So the job kind of works the same, very similarly. You can see that it doesn't have a while loop, but it's going to do the same things. It's going to go out and reach out and get a message from the queue. It's going to go ahead and process the message, and it's going to delete it from the queue. And the last step is actually the job actually exits. So there's two different ways you can do event-driven processing in container apps. Typically, the guideline is if you want lower latency, you typically want to go with an app. So an app is going to keep grabbing messages. And then also, and apps are better for things that are not CPU intensive. Whereas where jobs really shines is if you want to have basically this processing step, say it actually uses all the CPU that you have available. Then if you have it running it as an app, then it's going to basically take a long time to process one message before it gets to the next one. Or even if you can parallelize the work, you would end up kind of exhausting the CPU. So what a job is great for is that every job gets the CPU and memory that you allocate to it. So every job execution, I should say. So instead of having one app that perhaps in a while loop processes 20 messages and it takes a while to process each one, you can actually have a job like 20 job executions spin up that each process a single message. So there, jobs are really good for things like machine learning and AI, where you want to have, where you need to, run something for minutes, maybe hours, for every kind of message that you get in the queue. So this is how, so you still set up a scale rule for an event-driven job, but the rule actually works very differently. So for an event-driven app, we look at the rule, like we basically evaluate the rule, and then it decides how many replicas to spin up for your app. For a job, what we do is that in every scale polling intervals, in this case, every 20 seconds, we're going to execute this rule or evaluate this rule. So in this case, we're going to go and look at this queue. And then for every message, we're going to try to start up one execution of our job. So basically, and then it's gonna for every polling interval, we're gonna start up to 100 job executions. So if you can kind of picture that, how this works every 20 seconds, it's gonna go look at the queue. If the queue says, I have 5 messages in there, it's gonna go ahead and spin up 5 executions of my job. And then that job is going to go and process stuff, and it's going to basically delete that message off of the queue. And then 20 seconds later, it's going to go and look at the queue again, and then again, it's going to basically do the same math to figure out how many executions should I start this time around. So that's how a scale rule works in a job. It's you define the same scale rule, but they're kind of executed or evaluated a little bit differently, or they're evaluated the same way, but they're kind of the result is used a little bit differently. And I can show you a quick demo of that as well. So we can see that's our process.
Question actually, Anthony, for that one. So the difference between I guess the scale rules for the app versus say the job. So the app, it evaluates and then it basically says, hey, based on the queue length, however many messages I have, how many I want to process per replica, I spin up to that number of replicas, right?
Yeah.
And then for jobs, it's based on the execution instances. So do those map one-to-one to replicas? Is there still that concept in jobs? How does that look?
Yeah, so within the job, by default, every execution, you'll get one replica.
Okay.
But you can actually set a parallelism setting
Mhm.
in jobs so that if you want 5 replicas to spin up for a single execution, you can do that. But that's a very advanced scenario, and I would say
Okay.
most of the time, you probably want to leave it at 1,
I gotcha.
and just spin up more executions because it could get
Nice.
confusing, when you can kind of spin up an execution and that itself has multiple replicas, and each
Yeah.
replicas can have multiple containers. And then I don't know, I can't put all that in my brain. So
Yeah. So I'll just
um,
stick with the one execution per one
exactly,
replica
the
then.
one-to-one mapping is all my little brain can handle. And I'll just kind of finish off with a quick demo of that. You might have seen this demo before already, but I'll kind of quickly show you again. So I have a job here that listens to a queue. So listens to a queue. It's basically looking for a URL to videos, and it's going to go and for every URL, it's going to download the video, and then it's going to run it through the OpenAI Whisper model to transcribe it to text. Um, so yeah, so let's just run it. So if I head over, I actually need to go back to my PowerPoint here, grab myself a link to a video, and then I will head over to the service bus queue. And then within the queue, I think I can open up the service bus explorer, and then I can send some messages. So I'll go ahead and paste in the video URL, and I can actually send maybe 5 of these messages. So now 5 messages are on the queue, and every, I think, 20 seconds or so, we're going to evaluate the scale rule. So the next time it evaluates, so hopefully I can go back there fast enough. And I look at execution history. You can see that it already found the jobs, or like that they found the 5 messages, and then it kind of did the math and says I need 5 executions to start. So it started the 5 executions. It's going to take a few minutes to run, so I'm not going to go through all those. I'll kind of show you one from yesterday or this morning. And you can see the results here of the transcription. So you can see, yeah, it did a pretty good job transcribing the whole thing. So
That's super cool.
yeah, so that's a kind of like a whirlwind tour of scaling in container apps. So the key things to kind of watch out for are the differences between the different types of scaling, so horizontal scaling versus vertical scaling, and then how the scale rules are being used in conjunction with the type of workload that you're scaling, whether it's an app or a job. And yeah, so like the scale rule and the app or job, as well as the scale limits, are the things that they kind of work together to kind of make sure that your app is always scaled to the right part.
Yeah.
Cool.
One quick question actually with that as well. Jobs, like let's say I already am using Azure Container Apps, right? I'm familiar with Azure Container Apps. I have my environment. I have maybe like a couple apps in that environment. And now when I create a job, though, I don't have to create a new environment, right? Can I reuse that one that I've already been using? And then if so, like how do jobs and apps interact?
Yeah, so a job is basically like it's like an app. It's a resource that you can deploy to a container app environment. The main difference is that well, it's not really difference. A job is really a description of a job execution that you want to run. So if you actually go and deploy a job to the container app environment, nothing really happens. You're just basically defining a job to run. And then something kicks off a job. You can have a manual job, which you can
Right.
kick off by calling an ARM API, or you can have a scheduled job that just kicks off on a
Right.
schedule. And in this case, these job executions are being kicked off by a Kata scale rule.
And like the jobs and the apps, so they can still scale independently. They can have their own like replica counts within the environment and everything.
Yep. Yeah, they all work independently, and because they all live in the same environment, jobs and apps can talk to each other. So you can have some pretty cool scenarios where a
Awesome.
job can be running and it can actually call back to the app and let it know how things are going, things like that.
That's super cool. Thank you.
Yeah. And I'll kind of quickly tackle a couple of questions here while Mike is setting up. Let's see here. So Dipesh would like to know, scaling individual jobs, say we specify 30 seconds, but in my experience, it would be evaluated only after the previous execution has completed. That I have not seen. I think the evaluation of the scalables are pretty quick. So usually the evaluation is like it's basically Kata taking a peek at the queue and seeing how many, like in a case of a queue, it would kind of take a peek at the queue and see how many messages there are, and then it does a quick math, and then it kind of recommends 4 replicas, and then 4 executions, and then it tells Container Apps to start 4 executions of your job. So it shouldn't take that long. But yeah, but if you're seeing something different, let me know. There's a question about my Azure portal looks much better. I don't know. I just made it much larger. I don't know. I think this is the standard stuff. I don't really customize anything. I don't know. Maybe it's a new improvement. I don't know. Cool. So with that, I also want to kind of quickly bring up, there was a question about Azure DevOps earlier. So if you just Google or Bing for Azure Container Apps self-hosted agent, the first thing that comes back should be an article on how you can set up a self-hosted agent for either Azure Pipelines or GitHub Actions. Oh, and I just realized I showed you the screen, or I typed stuff on my screen without showing it. So you end up with this article if you Google or Bing it. Over to you, Mike.
Google or Bing. Yeah, I use Bing. I'm a big fan of Bing. But yeah, to each their own, I understand. That was awesome, Anthony. So yeah, like Anthony said, we were going to do a little kind of troubleshooting observability recap. And the reason I say recap, and I will share my screen while I do that, is none of this is new. But we continue to get questions on different places in social media around, hey, how exactly do I look at my logs? And I see that we have logs and metrics and log streaming. And so I'm going to go ahead and present my screen. Hopefully it'll let me choose the right screen. Yeah.
Mike's being swallowed by his background.
I know. I noticed that. I even switched shirts because my other tan shirt was even worse.
Yeah, it was like Homer Simpson kind of backing into the bush.
Once I look over to the left, stop it. Once I share this and I can look straight at my screen, it seems to get better. So it's not letting me share my second screen. There it goes. It's just a little delayed.
Are you okay with us putting that up?
No, not that one. No, I'm kidding. That's perfect. Okay, now I'll try to focus here so I don't disappear all the time here. So anyways, I wanted to go through some quick troubleshooting, just kind of cover the observability thing. So I went ahead and created a few apps this morning. It's the same app, just a simple album API. Oh, excuse me, just getting over a cold. We've used this demo app many times. So I'm going to start with the good version of this, which I meant to refresh. I'm going to hit refresh here. But while that's refreshing, here I've deployed this album API. And if we look here at the containers, I am, if I go over here to health probes, I'm actually leveraging the liveness probe. And I have in my, in this album API C# code, I have a health good endpoint. And that endpoint just, basically returns a 200, just simulating that everything's good. If you're not familiar with health probes, that's something you can define at each container. There's multiple health probes. You have the liveness probe, which is going to go out and periodically make sure that your app is still alive. You have a startup probe, and you also have a readiness probe. And I apologize for the cough. The readiness probe is basically checking that your app is ready for that first time so that it can accept traffic. But anyways, this isn't a thing on probes, but I am leveraging these probes to return either a good, or in the case here, I actually created one with a wrong port because I want to kind of show what that looks like. It's a common error that happens. And then I actually have a health bad. And if we look at this, you will see this container is calling into, well, when I deploy this, you'll see it. And I'll actually set up a health bad endpoint so that it actually fails. So those are the apps I've created. Again, we have the healthy one here, and it's returning as it should. It's returning the list of albums. In addition, I didn't want to redo this because Anthony just did it. I sent a bunch of traffic, 100,000 requests over, I think it was 3 minutes. And so I did that about 15, 20 minutes ago. The reason I did that is because I wanted to show you when things are working good. So I'm actually going to show you metrics first. So here I ran 100,000 transactions against, or requests against, this album API endpoint. And I actually took a picture of what that looked like. Here's what all of those looked like when all 30 were running. So I actually allowed this to scale up to 30 instances. And so I just wanted to show you that I did that just moments ago. And so if we go here, so this isn't necessarily, oh, my whole screen went blank. You still see my, oh, that was crazy. This isn't necessarily troubleshooting per se, but it is definitely observability. So what I'm going to do is, here I am in my Health Good app. I'm going to scroll down here to monitoring, and I'm going to go into the metrics. So Anthony showed you, before I do that, Anthony showed you how you can come here to scale and replicas and click on replicas to see how many replicas are running. And like I showed you in that image here, I had 30 running about 10 minutes ago. It scaled back to 1, so that's why you only see 1 now. And soon it will scale back to 0 after it's gotten no traffic for about 5 minutes. But if I go down here and I click on metrics, this is kind of cool because you can kind of dig into, okay, so there's 30 replicas and it's serving thousands of requests, 100,000 over 300 seconds. So 100,000 over 5 minutes is quite a few requests per second. So if we go here, and what you can do is, of course you can select requests, and you can see, I can zoom in here. So what I like to do is I like to go up here, and I typically will say, I want to see just my metrics for the last hour or so. Another thing you can do is just highlight the area of the screen that you want to zoom into, and then let go, and it zooms into that area. So here's a couple of just ways to look at your metrics, and you'll see that we sent a ton of requests here. You know, we had 20,000 going at this point. It came down a little bit, back up to 20,000, and then that 5 minutes ended, or 300 seconds. Yeah, 5 minutes. And we went back to basically no traffic. Well, that's cool. That shows you your requests. Of course, if we want to look at CPU or memory, we can go and look at those also. But what I find really cool is if we look at the replica count. So this is much like that same page that Anthony showed you. But in this case, we show you how many replicas are running during this time. Kind of cool, but it gets a lot cooler. Sound effects, maybe, Cary? I mean, like, ooh, or something. That would be great. What I'm going to do here is I'm going to apply a splitter. So I'm going to click on this apply split. And when I zoom in like this, can you see me zoom in and like do little red marks like that? Yeah. So I'm going to click this apply splitting here. And I'm going to choose that I want to split these on not revision. What I wanted to actually do is I'm going to start over. I'm going to add a metrics. I'm going to add a metric of, I'm actually going to look at my requests. So I'm looking at my requests, and then I want to split. And the thing I want to split on is I want to split on replica. So now what we're going to see is we're going to see all of the requests that went to each replica. So ignore this first blue bar. That was me doing a quick test. We want to focus in on this area here. So I'm going to actually go like that. And what you can see is each of the 30 replicas, and we can't see them all here, but we can see that we have multiple replicas. And as I highlight them, you can see how many requests at that point we're going to each of the replicas. So this is just kind of cool to see. Not only are we spinning up those replicas, but we're load balancing across those replicas also, so that we're sending the optimal amount of requests to each one. So I just wanted to point this out. It kind of ties on what Anthony did for a great scaling demo, but then kind of pulls in the observability fact of how to look at that after the fact. And you can go back, quite a bit of time in history to look at your metrics. Typically, if I was to go here, here's that endpoint, and let's say I'm clicking Control F5 in there a few times, so I probably sent 10 more requests. If I waited probably 1 to 2 minutes, you'd see we'd get a few live requests that come through. So typically our metrics are a minute or two behind the real-time world. And that's also true for your logs. What was that, Cary or Anthony?
I was just saying that's super cool. Like you can use this to see like the different replicas and how they break down. And like, let's say I was running my container app and I'm trying to figure out like, hey, maybe I have like a performance issue or like a scaling issue somewhere. Like this would be a really useful view then, right? To be able to see like how many requests are being serviced by each instance.
And just to validate, I think it's more, just to validate that, hey, load balancing is happening fairly well, as you can see. Each replica is getting somewhere between 550 and 650, 750. Typically, you'll see the first replica, when you have a single replica, it'll get a lot of requests. Right. Ignore this blue one. This was a quick test I did beforehand. But often, it'll get a lot of requests, and then other replicas start spinning up and handling, and the blue bar goes down. So it is pretty handy. Since we're right here, I'm gonna remove this. I'm back to requests. Another thing I can do is I can split. This is something that I didn't learn for a long time on the container app team. I can split my requests on status code, which is really cool because, good thing here is almost all of my 100,000 came back with a 200. But you can imagine in a real world, you're probably getting a few more errors. But here you can look at, hey, what do my metrics look like for my requests over the last hour or day? And just get a real quick view on what's the status code coming back to my web API or my website. In this case, I only have one failed 404, probably because I mistyped the URL when I first went there. But the splitting stuff is pretty cool. All right, that's all I had for metrics. The rest of this, I'm gonna focus mostly on logs. And here's a question we get a lot. It's like, you know what I'm gonna do? I'm gonna switch to my wrong port. So this is an app, which obviously I defined the wrong port for the container, and it's not uncommon for folks to do this, including myself. I have done this multiple times, and I just want to kind of show you it's maybe not as obvious. I think we can improve here, but let me show you what happens today. So I'm going to go ahead, and I've already hit this here. I've hit the endpoint, and it's not coming back, which can't handle this request. Not totally surprising, right? Because I'm sending a request to port 80, but that's not the port I plugged in for this app. My container's listening on port 80. And how do I know that? Great question, Anthony. Great question. So let's go over here to revisions, and I'm going to show you. There's a couple different ways to get to it. This is the easiest way to get to the logs that you're probably most interested in. You can, of course, always come down here and just click on logs, and then build your own query to figure out, what revision, what app do I want to look at logs for. The easier way is come to your revision page. Pick the revision you're interested in. I'm running in single revision mode, so there's only one. I'm going to click on that. And then what we've done is we've added some handy links down here. So if you want to look at your console logs, so these are the logs that are coming out to your standard out or your standard error that your application's writing. And then you click on that link. If you want to look at the system logs, and these are log messages that the container app system behind the scenes is writing out to help kind of let you know what's going on. So these are really handy links. Let's go ahead and start with the console logs, which is typically where I go, because if I've done a good job, I've added logging messages to my application, especially if it's an error situation. But in this case, I'm using ASP.NET. A lot of logs are written out just by default. So I'm going to click here. And by default, because I use that link, you're going to see up here in the query, we're going to query one of the 2 custom log tables that we have. This is the console logs. I'm going to minimize this here for a minute. If you look over here on the left-hand pane, you'll see under custom logs, we have 2 tables. We have the console log table and we have the system log table. Those match up pretty good with those links I just showed you. So here we're doing a query that says, hey, go to this table and where revision name equals the specific revision that I just clicked on. And this is where I didn't have to figure out the revision, figure out the query. It's just there for me. I'm going to go ahead and just look at like the last, how long ago did I do this? I'm going to go at 4 hours because it might have been an hour and a half ago when I did this. And then I'm just going to click run. And so that's going to bring me back my console logs for the last 4 hours. I only need to look at a few. And then I'm going to scroll over here. And the column we're most interested in most of the time is the log column, the log _est. And so I'm going to expand that. And what we can do is we can scroll down through here and we can see, I'm looking for that message that I was looking for here. It will tell us that it's listening. I'm going to scroll down a ways. I may need to redo my error situation. This is definitely not working the way I wanted it to. Let's not give up. Right here. Thank you. So early on, when this app was spinning up and the container was spinning up, .NET nicely put out, hey, I'm listening on port 80. And that's because my container is listening on port 80 and the ASP.NET runtime is listening on port 80. So I'm listening on port 80, but when I hit the endpoint, it didn't work for me. So one of the first things you want to do is go check, hey, how did I set up my ingress for this application? And so what we do to do that is we click here on ingress over here on the left, and we will quickly see, now this has just prompted me that I'm going to lose this query. That's what this prompt is. And that's fine. You can save this query if you want, but we all know we can go back to revisions and with one click, be right back here. So I'm going to say, yep, I'm going to discard my changes. And we're going to go look at the ingress. So ingress is enabled and I'm accepting traffic from anywhere. That's another common problem is if I maybe did this instead, I would only be able to hit this from inside the environment, which basically means one app could call another is kind of the basic thing that is. But in this case, I want to be able to hit my app inside that environment from out in anywhere in the internet. So that's one thing to look for. Make sure your ingress traffic setting is right. But then the big one, the most common one is right here. I put 8080, which is another very common port. And in fact, the reason I put that is because I wanted to mention in .NET 8, which is early in its makings, the default port is likely going to be 8080 rather than previously for ASP.NET, it's always been port 80 is the default. So just a little trivia thing there if you want. So I put 8080 here, and I'm not using .NET 8. And so my ASP.NET app is listening on 80. And so that causes this mismatch. Anthony and I specifically have talked about how could we provide an actually better, more obvious message, maybe even at this point when you're putting in your port and actually go maybe inspect that container. And we haven't come up with a great way, so that's why this hasn't happened. But we'd like to improve this. But because it's so common, I wanted to show folks how to kind of diagnose that and understand, hey, I have a port mismatch, therefore I need to go ahead and change that to 80, save my changes. It will fairly quickly update the ingress for my application. And then what we'll do when that finishes, I'm going to close that as soon as this updates. And if it doesn't in a second, we'll come back. When it does update, I can go hit that endpoint and it's going to work. So I've solved my problem. So that's how using the console logs can really help solve or diagnose what the problem might be. And now we updated that. I should be able to come back to, this one, wrong port. And if I go back to the overview and we launch that endpoint again, we should actually see. So that app is possibly still restarting. It changed the ingress, and I believe it restarts when that happens. This is going to come back and work. Trust me, I don't know why it's so slow. It shouldn't be. But yeah, fixing that ingress is a great thing there. There we go. Okay, so we got to our app, and I can hit albums, and I see my albums. So we've resolved that port mismatch. System logs. So we talked about system logs also. So if you haven't logged wonderfully in your application, or you didn't expect a place where you needed to, I'm just going to go back to that same one here. I'm going to go back to revisions. I'm going to click here on this again, and this time I'm going to click on system logs. So my typical pattern is hit the endpoint, see what I'm getting. If I'm having a problem, I'm going to go look at logs. And right now I'm showing you how to look at logs like in the past. And in a moment, I'll show you how to look at live logs. And typically, if my app is running and I'm hitting it on the fly, I'll actually go to the live logs and look at those first. I did this backwards because I had already created these errors. And so I created them like a half hour ago, so that y'all didn't have to wait for me to deploy and create these errors. But you can look at system logs also, is my point. You come here, click on the query. We're gonna put that query up here momentarily. There we go. Again, it's just saying, hey, where revision name is equal to the revision I care about. Show me all of my system logs. Now I have the last 24. I hit cancel. I hit cancel at the exact wrong time. I'm just gonna say, show me the logs for the last 30 minutes. And here I'll be able to go through my system logs, which I just created an error. I'm going to go like this and click that one more time. There we go. And so here I can go through my system logs and kind of get an idea for what does ACA, the system, say is going on. If we scroll over here to the right, we'll find that log column again. And you can just see some of the different messages. And we we put out a lot of messages around when we're doing some scaling. Like here, we woke this thing up. We woke the revision up, and we scaled from 0 to 1 replica. And here you'll see the replica went to sleep. So we scaled from 1 to 0. And you'll see a number of other types of messages. You'll see when we start a container, when we pull an image and things like that. Kata puts out logs also in here. So there's a lot of good information when you're troubleshooting something and you've gone and looked at your app logs or your console logs, I'm sorry, and you're still having a problem. This is a great place to go and try to piece together what's actually going on.
So Mike, just quickly
what I do. I'm sorry, Cary, go ahead.
Quick question. And so basically system logs is just like all the stuff that we as Azure Container Apps emit for you in terms of logs. And console logs is like the stuff that you emit yourself and put into your application, right?
Exactly. In fact, here's that app that I was just using. I didn't mean to close it. In a minute, I'll just show you. I was just doing some console write lines, especially early in development. I know we have interactive debuggers, and that's great for local. But sometimes, nothing beats some good log messages being put out to your console log. So don't be afraid to do those. You can always use log levels to reduce those in production, stuff like that. I want
Anthony, are you losing
here
Mike a little bit?
Here's some of those.
Yeah, I think we're losing you a little bit there, Mike.
Just return, and I have my health bad, which returns a 503.
Yeah.
Oh, did we get lag there?
Yeah, a little bit.
We're back.
Are we back?
Yeah, go move that antenna a little bit.
Yeah, I think we had a little lag there. You're killing me. Hey, is that better? Can you hear me now?
Yes, sir.
Yeah.
So here you'll see I
great.
have some of those. I have some of those health probes here. We have the health bad, the health good, and I have
Nice.
some console write lines. This is going to go to standard out. I did a console.err that's going to go to standard error. Both of those go to that console table, so they both go to the same, but just showing you how you can do both. So anyways, we'll get out of code. We don't want to look at code. All right, so those are our 2 log tables. The last thing I wanted to show you is if I go here to log stream, and I want to see what's going on right now. And in fact, let me go. This is wrong port, which is now working. So here we're looking at our live stream. I'm actually going to clear this. And what I'm going to do is I'm going to drag this over so it's just part sized. So this is the URL I'm hitting over here. And as I hit it and refresh, you'll see, if I can find the F5 key, over here, you'll see, I did not mean to reload the whole screen. That's my bad. Rookie mistake. We'll wait for that to come back up. Sorry about that. All right, here we go. I'm going to clear that again, and then I'm just going to hit F5 so I don't refresh everything. But every time I hit this, you can see more logs are coming out. So I'm seeing those real-time console logs come out right here. I can also see real-time system logs. If I click on this, it'll connect, and I'm seeing the system logs. Typically, when things are going well, I'm actually not going to get a whole bunch of system logs. You'll get some, though, as you can see. These are a lot of these are the same ones we write out to the long-term logs around starting a container and pulling an image, so on and so forth. So again, you can look at your real-time system logs and your real-time console logs. What's cool is if you're using Dapper will show up as one of the containers. So if you want to look at just the Dapper specific error messages, you can do that as well. So that's kind of just a recap. You have your real-time logging. You have your kind of longer-term logging, which has a minute or 2 delay, but you can store for many, many days. And then you have your metrics, which I showed you, which that's more observability, you're not diagnosing stuff there necessarily. Although you might be looking at, hey, how much CPU am I using? That seems crazy. Why am I using so much CPU? And then the last thing I didn't mention, I'm not going to go into it, but if you want to connect to the console of the actual container that's running in up in Azure, you can do that. I can come here. I can choose which container. Again, I only have one container, which is typical. But if you had a sidecar container, it would show up and you could connect to that. And then I can just connect a shell to that container. And then what I'm going to get is I'm basically going to get a shell like I would expect. And I can go see what the files are. I can print out a file. I could maybe go tweak a setting even. So, of course, you wouldn't want to do this in production because you don't want to be messing with your containers. But in a development environment where you might want to go tweak a setting, you could do that right here by editing a file inside the console. So, yeah, those are the observability things I wanted to kind of point out and kind of some of the troubleshooting. We are working on a document that'll be out in the next few weeks, probably. That'll go over a lot of this in a very methodical way of, hey, here's what we recommend for troubleshooting. So,
yeah,
that's
thanks,
all
Mike.
I had.
Yeah, that was awesome. Yeah, I think like the most kind of common thing that people look into when they try to troubleshoot is not really kind of understanding the difference between console or app logs versus system logs, and that we actually have logs in 2 places. Yeah, like because different errors will show up in different places. So things like things that you log yourself from your app, or like a stack trace from your app, will actually show up in console log. But sometimes your app could perhaps be in a state where it wouldn't even start up. Like maybe you can't pull the image, or like there's a problem with the scale rule, things like that. In those cases, system logs are your friends. And it's good to be able to, it's good to know about both of those, and actually, be able to look at both of those things. Yeah,
exactly. And again, typically I look at console logs first because I assume my app's going to start up, and I assume it's bad code on my part. But as Anthony said, If you don't think that's the issue, maybe you look at system logs first to see if there's an obvious error that was starting up.
Yeah,
Yeah,
because
my code always works.
Yeah. What's that?
Oh, it's not
My
your code always
doesn't
works. So,
always
you know,
work.
Yeah.
I just always look at system.
Yeah. So I always
Yeah.
get Cary to write my code, and it's all
No,
good.
don't do that. Don't do that.
But yeah, actually, a common
weird.
weird
I
one
always
that
have-
comes. Yeah, a weird one that comes that comes up a little bit commonly is you do see some console logs, but you actually end up running out of memory in your app. You actually don't see your app logging that in console log because by then it's too late. So you would actually see, like like you might see some console logs that say, "Hey, my app's healthy," and then just all of a sudden just silence. When that happens, also flip over to the system logs, and quite often you might see that your app is running out of memory, and then you would just kind of change it so that you allocate it more.
Yeah. And again, I just wanted to point out this revision details sidebar is a really handy place to start, because you can, especially if you're in multiple revision mode, this can be really handy if you're doing like traffic splitting, because if I had 2 or 3 revisions here and they were splitting traffic, maybe 50, 50, 25, 25, 50, I can go to just any specific revision, not only look at the logs, both console and system, but I can also get a revision specific URL. So if I just want to test against a specific revision, I can hit that right here. I don't have to rely on that traffic splitting to maybe give me the right revision that I want. So there's a lot of handy links right here over in the revision details. Cool. Thanks. I appreciate the time. Hopefully that helped somebody.
Yeah, it helped me. I actually learned some stuff about the different things you can do in metrics. So I didn't even know that you could see the traffic across different replicas. So
Yeah.
Awesome.
We all learned something new.
One thing I didn't point out is we also have alerts. I'm not going to go into it, but you can set up alerts that can look at metrics or actually run log queries. And if this happens, you can have an email or a text message sent somewhere. So you don't have to come do this using the portal. You can kind of automate those and create alerts based on pretty much all the things we just looked at. So yeah, it is really handy. The metrics and alerts can really be handy.
That's super
I
cool.
will stop sharing and give it back to you.
Awesome. Yeah. So I don't see too many more questions in the chat. So yeah, so I think we can wrap it up here. Thanks, Mike. Thanks, Cary, for joining us on this stream. And thanks everybody for joining us. I'll once again put up the link to our newsletter so y'all can go check it out. But until next month, have a great month, and we'll see you again in November. Wow, it's almost the end of the year.
Yeah. Thank
Thanks,
you.
everybody.
Have a great time.
Have a good one.
Good day.